Hello, my good friends. Derek Deschamps here for Internetworking Influencers, your source for free Cisco certification training for network engineers. Welcome to Day 2 of our free CCNA 200-301 training course. Internetworking Influencers CCNA 200-301 training course is comprised of 18 videos, each focusing directly on a set of specific items on Cisco's official exam topic list. Today's episode will cover Item 1.1, explain the role and function of network components, including routers, L2 and L3 switches, next-generation firewalls and IPS, access points, controllers such as Cisco DNA Center and WLC, endpoints, and servers. Item 1.2, describe characteristics of network topology architectures, including 2-tier, 3-tier, spine leaf, WAN, small office, home office, or SOHO, and on-premises and cloud. Item 1.3, compare physical interface and cabling types, including single-mode fiber, multi-mode fiber, and copper, connections including Ethernet shared media and point-to-point, and concepts of PoE. Item 1.12, explain virtualization fundamentals, including virtual machines. And lastly, Item 5.5, describe remote access and site-to-site VPNs. As a reminder, today's video has a set of free practice questions that are available on our website at internetworkinginfluencers.com that will help you brush up on the topics you learned today. The questions are a true representation of the types of questions you'll face on the actual exam, so be sure to check those out once we're done. Today we're going to start things off by looking at the primary function of each network component. It is important to note that this section is intended to be a brief overview only, as we will be covering most of these components in much greater detail throughout the course. An endpoint is any device that communicates across a network. For example, a network-connected desktop, laptop, or server are all considered endpoints. A Layer 2 switch is used to connect endpoints to a network. A Layer 2 switch makes forwarding decisions based on destination MAC address. For example, with this network, a Layer 2 switch has been used to connect 3 endpoints to the network. Now, if host A attempts to send data to host C, the Layer 2 switch will forward the data to the correct host based on the destination MAC address. A router is used to connect networks together. A router makes forwarding decisions based on destination IP address. For example, with this network, a router has been used to connect 3 networks together. Now, if a host on network A attempts to send data to a host on network C, the router will forward the data to the correct network based on the destination IP address. A Layer 3 switch, also known as a multi-layer switch, performs the functions of both a Layer 2 switch and a router. For example, with this network, a Layer 3 switch has been used to connect 6 endpoints to 2 different networks. Data sent within a network will be forwarded based on destination MAC address, while data sent between networks will be forwarded or routed based on destination IP address. A firewall is used to control the flow of traffic between networks. A firewall blocks or allows traffic based on predefined security rules. For example, a firewall is typically used between a local area network or LAN and the internet to control which traffic is allowed to flow between networks. Firewalls can be categorized as one of 2 types. A stateless firewall retains no information about network traffic and does not consider previous traffic when making filtering decisions, while a stateful firewall retains information about network traffic in a state table and considers previous traffic when making filtering decisions. For example, a stateful firewall can block or allow traffic based on traffic patterns. Most modern firewalls and all Cisco firewalls are considered stateful firewalls. Cisco firewalls are configured by adding interfaces to security zones. Security policies are then applied to control which traffic is allowed to flow between zones. For example, a typical configuration consists of an inside zone for the local area network and an outside zone for the internet. A security policy is then applied to allow traffic initiated from the inside zone to reach the outside zone, while preventing traffic initiated from the outside zone from reaching the inside zone. This configuration allows hosts on the local area network to access the internet, while preventing hosts on the internet from accessing the local area network. A third zone, called the demilitarized zone or DMZ, is often added to provide a place for servers that need to be accessed from the internet. For example, web servers, external mail servers, and external DNS servers are often placed in this zone. Security policies can then be applied to allow systems on the internet to access the DMZ servers without exposing the inside zone or local area network. An intrusion prevention system, or IPS, is used to monitor network traffic to detect and block potential security threats. An IPS is effective at preventing network attacks, viruses, and worms. For example, an IPS is typically installed in line between the local area network and the firewall, so that all traffic entering the network is routed through it. The IPS then compares the traffic to a signature database that tells the IPS how to identify security threats. When a security threat is detected, the IPS can log the event or block the offending traffic. A next-generation firewall, or NGFW, is a stateful firewall with many additional features, including application filtering, URL filtering, an integrated intrusion prevention system, or IPS, and advanced malware protection, or AMP. Besides being able to perform the functions of both a stateful firewall and an intrusion prevention system, a next-generation firewall can also be used to block traffic that is generated by specific applications or that is attempting to access specific URLs. For example, a next-generation firewall can be used to block the use of FaceTime or to prevent users from accessing Facebook. A next-generation IPS, or NGIPS, is an intrusion prevention system, or IPS, with the additional feature of contextual awareness. A next-generation IPS gathers detailed information about each host it's protecting, such as the operating system, installed applications, and existing vulnerabilities. This information is then used to increase accuracy and reduce the number of false positives. For example, if hosts on a network are running Windows 10, a next-generation IPS can focus on threats to that particular operating system. An access point, or AP, is used to connect wireless endpoints to a network. For example, with this network, an access point has been used to connect a wireless endpoint to the network. This will allow the wireless endpoint to communicate across the network with both wireless and wired hosts. Access points can be one of two types. An autonomous access point functions independently, while a lightweight access point, or LAP, is managed by a wireless LAN controller. A wireless LAN controller, or WLC, is used to manage multiple lightweight access points from a central location. For example, with this network, a wireless LAN controller has been used to manage multiple lightweight access points from a central location. Each lightweight access point will download both its configuration and firmware from the wireless LAN controller. Since all configurations are managed centrally, this greatly reduces the effort involved when managing a large number of access points. A network controller is used to control multiple network devices from a central location. A network controller also allows for network automation and programmability through the use of application programming interfaces or APIs. For example, the functions of a traditional network device, such as a switch or a router, can be divided into three planes. The management plane is used to access and manage the device. The control plane provides all the information necessary to forward data, including routing information, while the data plane performs the actual forwarding of data. With a controller-based network, the control plane functions for each network device are performed by a network controller, leaving the network devices to perform only the functions of the data plane. This greatly simplifies network management, since changes to the network can now be performed centrally on the network controller without the need to configure each individual network device. A network controller has two software interfaces, known as the northbound interface and the southbound interface. The northbound interface is comprised of application programming interfaces or APIs that allow software applications to communicate with a network controller. This allows software applications to access information about the network, as well as perform network configuration tasks. While the southbound interface is comprised of APIs that are used for communication between the network controller and the data plane of network devices. A virtual machine, or VM, is a software-based representation of a physical computer. Multiple virtual machines can be created on a single physical server. Each virtual machine has its own operating system and applications, and functions as a separate server. The virtual machines are created and managed by a process known as the hypervisor. The hypervisor is responsible for isolating the virtual machines from the physical server, and allocates each virtual machine a portion of the physical server's CPU, memory, disk space, and network bandwidth. In order to connect virtual machines to the network, each virtual machine is assigned at least one virtual network interface card, or VNIC. The VNICs are then connected to a virtual switch. A virtual switch is entirely software-based and behaves in a similar manner to a standard switch. The virtual switch is then connected to the network through the network interface cards of the physical server. Now that we've had a brief overview of each network component, let's take a look at how they can be organized into various LAN and WAN architectures. A local area network, or LAN, is a network that is contained within a small geographical area, such as an office, building, or university campus. While a wide area network, or WAN, is a network that connects LANs together over large geographical distances. Today we will look at some common designs for both types of networks. For small local area networks, also referred to as small office home office, or SOHO, a single wireless router is often used for all network connectivity. A wireless router performs the functions of a wireless access point, a layer 2 switch, a router, and a firewall in a single device. For medium-sized local area networks, a two-tier model, also referred to as a collapsed core model, is often used. With a two-tier model, the network is divided into two layers, the access layer and the distribution layer. Access layer switches are used to connect endpoints to the network, while distribution layer switches are used to connect access layer switches together and are responsible for routing traffic within the local area network. For large local area networks, a three-tier model is often used. A three-tier model introduces a third layer called the core layer. Core layer switches are used to connect multiple distribution layer switches together and act as a high-speed backbone for the network. In data centers, a spine-leaf topology is often used. A spine-leaf topology divides the network into two layers, the leaf layer and the spine layer. Leaf layer switches are used to connect endpoints such as servers to the network, while spine layer switches are used to connect leaf layer switches together. Each leaf layer switch is connected to all spine layer switches. This ensures that endpoints can be reached by crossing no more than one spine layer switch. When using a spine leaf topology, all traffic is distributed evenly amongst spine layer switches. This means if a spine layer switch was to fail, network performance would only be impacted slightly. This also means that when the network reaches capacity, it can be easily upgraded by adding another spine layer switch. So now let's take a look at some common wide area network designs. So as I mentioned earlier, wide area networks are used to connect local area networks together. Wide area networks are typically owned and managed by WAN service providers, who offer various types of WAN services. A lease line is a type of WAN service that acts as a dedicated point-to-point link between two LANs. When a lease line is used to connect local area networks together, it functions similar to a physical cable. Some of the more common lease lines include T1s and T3s. Metro Ethernet is a type of WAN service that is based on Ethernet standards. When Metro Ethernet is used to connect local area networks together, it functions similar to connecting the networks together using a Layer 2 switch. Local area networks are connected to the service provider's Metro Ethernet network using standard Ethernet interfaces. The link between a local area network and the Metro Ethernet network is referred to as the User Network Interface, or UNI, while the connection between UNIs is referred to as the Ethernet Virtual Connection, or EVC. There are a few different types of Metro Ethernet services. An Ethernet line service, also known as E-LAN, creates a point-to-point connection between two UNIs. An E-LAN service is ideal for connecting two LANs together. An Ethernet LAN service, also known as E-LAN, connects multiple UNIs in a full mesh configuration. An E-LAN service is ideal for connecting multiple LANs together, allowing all LANs to communicate with each other. And lastly, an Ethernet tree service, also known as E-tree, connects a single root UNI to multiple leaf UNIs in what's referred to as a hub-and-spoke configuration. This configuration allows communication between the root and leaf UNIs, but does not allow communication between leaves. An E-tree service is ideal for connecting a central LAN to multiple remote LANs when the remote LANs do not need to communicate with each other. Another common WAN service is multi-protocol label switching, or MPLS. With MPLS, network traffic is labeled as it enters the MPLS network, based on its destination. Labels are then used to determine where to forward the traffic as it crosses the MPLS network. When the traffic exits the MPLS network, the label is removed. This labeling technique allows MPLS to work with many different types of traffic. With MPLS, a device at the edge of a LAN is known as the customer edge, or CE, while a device at the edge of the service provider's MPLS network is known as the provider edge, or PE. CEs can be connected to PEs using various types of WAN services, including lease lines and Metro Ethernet. This allows LANs to be connected to each other, regardless of the type of WAN services they have available at their location. An MPLS Layer 3 VPN is a type of MPLS WAN service where the service provider participates in routing traffic, rather than simply providing a direct connection between LANs. With MPLS Layer 3 VPNs, each CE forms a neighbor relationship and exchanges routing information with its connected PE. This routing information is propagated throughout the MPLS network and shared with the other CEs. This allows new LANs to be connected to the MPLS network without having to make routing changes at each site. Another common WAN service is a site-to-site VPN. With a site-to-site VPN, two LANs are connected together across the internet using a secure tunnel. All traffic sent between the two LANs traverses the tunnel and is encrypted. The tunnel is created and secured using the IPsec protocol suite. A site-to-site VPN can be created between two routers, two firewalls, or a combination of both. A remote access VPN is another type of VPN that allows a single user to securely access a LAN from the internet. With a remote access VPN, a VPN client is installed on the user's system. The user can then use this client to create a secure tunnel between their system and a firewall or router at the edge of the LAN. In this case, the tunnel is typically created and secured using the TLS protocol or IPsec. Now that we know how LANs and WANs are designed, let's take a look at cloud architectures. Cloud computing is the delivery of on-demand computing services over the internet. Cloud computing allows companies to rent computing services from cloud providers, rather than own their own servers and data centers. Cloud computing services can be divided into three main types. Infrastructure as a Service, or IaaS, provides on-demand access to virtual machines. Platform as a Service, or PaaS, provides on-demand access to software development environments, while Software as a Service, or SaaS, provides on-demand access to web-based applications. There are three different types of cloud computing deployments. With a public cloud, the cloud infrastructure is shared by multiple organizations. A public cloud is owned and managed by a third-party cloud provider, such as Microsoft, Amazon, or Google. With a private cloud, the cloud infrastructure is used by a single organization. A private cloud can be located physically in a company's own data center, also referred to as on-premise, or hosted by a third-party cloud provider. While a hybrid cloud is a combination of both public and private clouds. A LAN can be connected to a third-party cloud provider using a site-to-site VPN across the internet, or using a WAN service such as Metro Ethernet or MPLS. A site-to-site VPN provides greater flexibility to switch cloud providers, since it can be easily moved without having to coordinate with a WAN service provider. While a WAN service, such as Metro Ethernet or MPLS, provides greater reliability and performance, since it is a dedicated connection that does not traverse the internet. A LAN can also be connected to a cloud provider through an intercloud exchange. An intercloud exchange is a company that provides connectivity to multiple cloud providers. An intercloud exchange offers the flexibility to easily switch cloud providers while offering the same performance and reliability as a direct Metro Ethernet or MPLS connection. For today's last topic, we'll look at how network components are connected together using various types of physical interfaces and cabling. An unshielded twisted pair, or UTP cable, is a type of cable that consists of copper wires that are twisted together into pairs to help reduce electromagnetic interference. A standard UTP Ethernet cable, such as a Cat6 or Cat7, consists of 8 copper wires, which are twisted together into 4 pairs, and terminated on the pins of an RJ45 connector. The Institute of Electrical and Electronics Engineers, or IEEE, has developed several Ethernet standards for the various network speeds using UTP cabling. Most Ethernet standards that use UTP cabling have a maximum cable length of 100 meters. With the 10-base-T and 100-base-T standards, only 2-wire pairs are used for communication. The 2-wire pairs are connected to pins 1, 2, 3, and 6 of the RJ45 connectors. PCs, routers, and wireless access points transmit on pins 1 and 2 and receive on pins 3 and 6, while switches and hubs transmit on pins 3 and 6 and receive on pins 1 and 2. A 10-base-T and 100-base-T straight-through cable takes the wires connected to pins 1, 2, 3, and 6 on one end of the cable and connects them straight through to pins 1, 2, 3, and 6 on the other end of the cable. A straight-through cable should be used when connecting 2 devices together that transmit on different pins. For example, a straight-through cable should be used when connecting a device that transmits on pins 1 and 2, like a PC, router, or wireless access point, to a device that transmits on pins 3 and 6, like a switch or a hub. A 10-base-T and 100-base-T crossover cable takes the wires connected to pins 1 and 2 on each end of the cable and crosses them over to pins 3 and 6 on the other end of the cable. A crossover cable should be used when connecting 2 devices together that transmit on the same pins. For example, a crossover cable should be used when connecting 2 routers together, since they both transmit on pins 1 and 2. With the 1000-base-T standard, all 4-wire pairs are used for communication. The 4-wire pairs are connected to pins 1 to 8 of the RJ45 connectors. With the 1000-base-T standard, devices can transmit and receive simultaneously on each wire pair. A 1000-base-T straight-through cable takes the wires connected to pins 1 to 8 on one end of the cable and connects them straight through to pins 1 to 8 on the other end of the cable. While a 1000-base-T crossover cable takes the wires connected to pins 1 and 2 on each end of the cable and crosses them over to pins 3 and 6 on the other end of the cable. It also takes the wires connected to pins 4 and 5 and crosses them over to pins 7 and 8. Another common type of network cable is a fiber optic cable. A fiber optic cable consists of 2 thin strands of glass which are used to carry signals of light from end to end. When 2 devices are connected together using a fiber optic cable, each device will transmit on a different strand. There are 2 common types of fiber optic cabling. With multimode fiber, an LED transmitter is used to send a signal of light through a glass core. This light can travel at multiple angles, which are referred to as modes. With single mode fiber, a laser transmitter is used to send the signal of light straight down the center of a smaller glass core. Single mode transmitters are typically more expensive, but can reach greater distances. There are several IEEE standards for the various network speeds using fiber cabling. Some standards that use multimode fiber can reach a maximum cable length of up to 550 meters, while some standards that use single mode fiber can reach a maximum cable length of up to 40 kilometers. When determining which type of cabling to use for a network, there are a few different characteristics that should be taken into account. Most UTP standards have a maximum cable length of 100 meters, while some fiber standards can reach a maximum cable length of 550 meters for multimode fiber and up to 40 kilometers for single-mode fiber. UTP has a lower cost than fiber, but is also more susceptible to interference. Power over Ethernet, or PoE, is the ability to provide power to a remote device using a standard UTP Ethernet cable. With Power over Ethernet, a single UTP Ethernet cable is used for both power and data transmission. For example, a PoE-capable switch can be used to provide power to a device, such as a wireless access point, IP camera, or IP phone, using the same UTP Ethernet cable that is used for data. This allows the device to be installed in a location where a power point is not accessible. A device that provides power over Ethernet, such as a PoE-capable switch, is referred to as power sourcing equipment, or PSE. While a device that is powered by PoE, such as a wireless access point, IP camera, or IP phone, is referred to as a powered device, or PD. Before providing power, a PSE sends out a periodic probe to detect when a PD is connected. Once a PD is detected, the PSE uses similar probes to negotiate the PD's power class. The power class indicates the maximum amount of power the PD will be provided. The PSE then supplies power to the PD based on its power class. This process ensures that power is only provided to PoE-capable devices. Over the years, several IEEE standards have been developed for Power over Ethernet. The original PoE and PoE Plus standards only allow 2 pairs of wires in a standard Ethernet cable to be used for power, while the latest UPoE and UPoE Plus standards allow all 4 pairs of wires to be used for power. This allows PSEs to output a greater amount of power per port. And that brings us to the end of Day 2 of Internetworking Influencers CCNA 200-301 training course. Don't forget to complete the free practice questions for today's material, which can be found on our website at internetworkinginfluencers.com. The free questions will help highlight the key points that Cisco will expect you to know for the exam. Also, if you enjoy our free training and would like to show your support, please check out our Patreon page. We offer numerous perks to our supporters, ranging from additional practice questions and detailed study notes for each video, to direct access to our instructors to answer any questions you might have. I'll be back next time for Day 3, where I'll cover TCP and UDP protocols. I'm Derek Deschamps for Internetworking Influencers. Thanks for watching.